This program is powered by thevirtual.show, making your offline events virtual. Ladies and gentlemen, the host of WEBIT Virtual, Dr. Plamen Rusev.
Your wife.
Hello and welcome, wonderful WEBIT community from all around the world. It is always a great pleasure to be together, to unite and to connect our thoughts and our great, beautiful intentions to create the better future for our world. Of course, in these challenging times, it is virtual, and we were among the first to start this back in April last year. Since then, over 60 events, over a million attendees, and all of these thanks to you, our beautiful community from all around the world. Today, we shall be meeting you with and having a very interesting discussion with someone who said that there is only a limited amount that AI researchers can do to influence the evolution of global policy on AI. Perhaps the most important thing we can do is to design AI systems that are to the extent possible, provably safe and beneficial for humans. Let me introduce you my guest.
Stuart Russell is a professor of computer science at the University of California at Berkeley, holder of the Smith-Zadie Chair in Engineering and director of the Center for Human-Compatible AI. He is a recipient of the IJC AI Computers and Thought Award from 2012 to 2014, held the Cherie Blaise Pascal in Paris. He is an honorary fellow of Wadham College, Oxford, an Andrew Carnegie Fellow, and a Fellow of the American Association for Artificial Intelligence, the Association for Computing Machinery, and the American Association for the Advancement of Science.
Professor Russell, such a pleasure to have you with us. Thank you so much for joining.
Wonderful to be here.
We are absolutely excited to start our questions because there are so many, and we expect even more from our community. But to start first with maybe the most challenging one, because everyone wants to hear the answer here. So Russell, do you really think that the current approach to AI is sort of fundamentally mistaken?
I do actually, yes. And I say that having described the current approach in my textbook in great detail. So the way we do AI, and in fact, the way we do a lot of other important areas of science and engineering, including control theory and operations research and statistics, is that we define an objective, usually a mathematically defined objective, which we then create machinery whose purpose is to find the best solution for that objective. And we're all familiar with that idea. When, you know, if you use a navigation app on your phone, you tell it the destination. You say, you know, I want to go to San Francisco airport, and then it will find a way to get you to the airport and give you the instructions to do so. And that works fine when we have systems with limited capabilities. Systems that we test in the lab, systems that operate in virtual closed worlds like chessboards and Go boards and so on. But in the real world, it just doesn't work. The main reason being that we cannot specify objectives correctly in the real world. And this is a problem we've known actually for thousands of years, you know, going back to King Midas in Greek mythology, who was a king who was very greedy, and he asked the gods that everything he touched should turn to gold. And of course, the gods grant his wish. They give him exactly what he specifies. They satisfy his objective. And then he finds out that his food and his drink and his family all turn to gold, and he dies in misery and starvation. And pretty much every culture has stories, proverbs, legends around this point. be very
Absolutely.
careful what you ask for.
So, if I understand your words correctly, it's not about the creating these super capable machines that will one day wake up and defy us all. It's if the problem is if they do exactly what we tell them to do. Is this where the challenge comes?
Yes, that's right. And I think Hollywood and the movie industry mostly gets it wrong. In most movies, the problem happens when the machine becomes conscious by some mysterious process that nobody understands. And then only when it's conscious does it start to defy human beings and take over the world and, you know, all the rest of it. And that's a completely misleading storyline for several reasons. One is that, you know, we have absolutely no idea how a machine could become conscious. In fact, we have no way of telling whether it has or not. I mean, for all I know, my laptop is conscious, but I have no way of telling. And secondly, even if it did become conscious, it's still running the software. The rules of operation of the software of the, you know, the C++ program or the Java program or whatever it is, those rules didn't change just because the machine became conscious. And it's still going to do exactly what the program dictates. And so the advent of consciousness wouldn't actually change anything in our predictions about how the machine is going to behave. And so most people have thought of this possibility as science fiction because, you know, it's not realistic that machines are suddenly going to wake up and become conscious. But in fact, the problem is competence. And competence is something that we are investing hundreds of billions of dollars to create.
So I've heard many times the saying that if you have to bid on something and one of these things is stupidity when it comes to humankind, you'd better bid on stupidity because it's kind of the always chosen. So I guess that's kind of a threat, serious threat in this case. I already see questions, and one of them is, could you please share with our audience your model that you call probably beneficial AI and the 3 principles that includes?
Sure. So what I'm trying to do is to get away from what we call the standard model. So the standard model being where we specify some objective in precise mathematical terms, and then the machine optimizes the objective, finds the best way to carry out some behavior that will achieve the objective. And if it's possible that the objectives that we try to write down are wrong, then the machine had better know that. Right? The problem comes from the machine pursuing the objective as if it was, in fact, the gospel truth. And so I developed this new approach around the idea that the machine knows that it doesn't know what the objective is. So the first principle is that essentially benefit to humans is the only true objective, right? And in economics, the language that's used there is the language of preferences. That out of all possible futures, there's one future that we might prefer to another. And so when I use the word preference, I'm talking about an entire future being preferable to another entire future for a given person. So the first principle is that the machine's job is to help realize human preferences. The second principle is that the machine knows that it doesn't know what those preferences are. And that turns out to be absolutely crucial. You might call it a kind of humility, and it's this humility that ends up protecting us. The third principle essentially connects the human to the machine. The third principle says that the evidence for human preferences is human behavior. And if you like, this provides a grounding of what we mean by preferences. The connection between human preferences and human behavior is a complicated one, right? It's essentially why we have a brain in the first place, right? It's to turn our preferences into action so that eventually we get what we want. But we make mistakes, we lose our tempers and do things that we regret. We are sometimes short-sighted, that greed or eagerness takes over our better judgment. So there are lots of ways in which the connection between our underlying preferences and how we behave is a complicated one. But so those are the three principles, right? Human benefit, machine uncertainty about what human benefit is, and a connection between preferences and behavior. And that is what allows the machine to learn more about what our preferences are. And we can actually turn this into a mathematical framework. And the important characteristic of this framework is that no matter how well the machine solves this problem, the results are going to be beneficial to us. In fact, the better it solves the problem, the better the outcome will be for us, as long as we get all the details right.
I would like to ask a second question here to
Sure.
get a better understanding. I'm not sure how many of our viewers have this. So you said that we have to build machines to ensure that their actions can be expected to achieve our objectives. But another question comes from this, that how does a machine take action in the service of our objectives when, according to your second principle, it doesn't even know what they are? So how does this work?
So it works as a long process of apprenticeship, if you like. And so there's sort of two parts to the question. One is, how does the machine actually learn anything about our preferences? And then the second part is, how does it act even when it has uncertainty about our preferences? So let me actually answer the second question first. So how does it act when it doesn't know everything about our preferences? So one thing it can do is we think of this as minimally invasive, which is, when doctors talk about minimally invasive surgery, they mean surgery that fixes the thing that needs to be fixed and doesn't do a lot of damage to the rest of your body, right? So it's the same basic idea. If the machine knows that you prefer, let's say, coffee over tea, and that's all it knows, then if it can find a way to make you a cup of coffee without changing the rest of the world, then it will do that, right? So, I like coffee in the morning, sometimes over tea, but, I also like the atmosphere to have less pollution. So what does that mean? It means make the coffee, but don't change the amount of pollution. If the machine doesn't know if I make more pollution or less pollution, leave the pollution alone, right? So leave alone those parts of the world where the machine is uncertain about my preferences and which direction I would like it to be changed. So that's the minimally invasive idea. And you can take that to an extreme, in fact. So even if the machine knows absolutely nothing about my preferences, nothing at all, it can still be helpful to me. How? By changing the world in such a way that I now have greater freedom of action, right? That there are more things I could do than I could do before. An example of that would be if I've forgotten my password, the machine can tell me my password. And now I can do things that I couldn't do before, and nothing else has changed. And that's beneficial to me, assuming that my actions are actually beneficial to me on average. when I have the freedom to do them. And then the other question is, how does the machine learn more about our preferences? And this is the third principle, right? By observing our behavior. And we can think of this in, in simple ways, right? It can watch me, ordering pizza, and it learns something about, which kind of pizza I chose. It doesn't assume that, necessarily for all time, I'm banning pineapple pizza. It just says, yeah, sure, you ordered the sausage and pepperoni, so that updates my belief about what kinds of pizza Stuart likes. But the evidence available to machines is actually enormous. So everything we do as individuals, every choice we make, every choice we don't make, right? Even just the choice to be sitting there doing nothing, right, is a choice not to do a whole range of things, and that conveys information. But also everything that's ever been written down, every television program that's been made, every novel, every film, every record, going back thousands of years of people trading camels for bushels of corn and so on. I mean, these are all records that convey information about human preferences. And so in the long run, it's inevitable that we are going to have actually a significant industry supplying this information. So if I'm a manufacturer of domestic robots, I don't want to have to worry about, okay, we want to sell these robots in Sofia. What are the preferences of Bulgarians, and how do we put those in the robot? I want to go to a preference corporation, maybe one that specializes in Bulgarians, and download a whole what we call a prior probability distribution, so expectations about what different types of Bulgarians like and don't like, so that our robots work fairly well out of the box. And then after they come out of the box, they're going to adapt to the
That will be a very challenging task for the machine, I'm telling you.
But adapting to the individual families that they live with, and the customs that they're surrounded by, and so on. But there is, I think, a great deal in common among human beings in their preferences. I think we always talk about differences, but in fact, we are all human, and we all have actually the major elements of our preferences are actually pretty similar.
So do you think that we as humankind are prepared or ready or will be prepared to control something which is more intelligent and maybe in the future more powerful than us? I mean, isn't it like an impossible?
Well, yes, it does sound like a contradiction that we're going to have power over something more powerful than we are. But we have no choice, right? They are going to be more powerful than we are. And we do have to retain power over them. So we better figure it out. And, in some storylines, in some novels and films, the solution that we find actually is to ban artificial intelligence altogether. And in fact, the first novel written about this in 1863 by Samuel Butler, a novel called Erewhon, actually describes a society where they have reached a crisis point in their relationship with machines and decided to get rid of all the machines. And so they, even though they know the technology and they have exquisite capabilities in machine design, they decide to get rid of it. And if you read Dune, the novel by Frank Herbert, which was also made into movies several times, the same thing. They, in fact, there it got a lot more serious. They had a massive galactic battle between humanity and the machines, and humanity wins the battle by the skin of its teeth. And then from that point on, intelligent machines are banned. So there are, despite the fact that they have intergalactic space travel and lasers and nuclear this and that and the other, they have no computers because they don't want to have computers. So that's one solution. But the other solution is find a way to develop AI that is provably safe. And I mean provably. I don't mean, well, I've got some smart people and they're telling me that they've done a pretty good job, right? We saw that with nuclear power stations. All those nuclear engineers, they're all smart people. They all said they'd done a pretty good job. Many of them were living next to the plant, so they knew they'd better do a pretty good job. And yet we still had Chernobyl, we still had Fukushima. And so you can't rely on, the best wishes and earnest hopes of engineers and scientists. You have to rely on mathematical guarantees, and that means setting up the problem in the right way, so that if the machine solves the problem, the outcome is guaranteed to be good. And I've sketched an approach that has that property, but there's still an enormous amount of work to do. And if it might well be that the industry, which is really, I would say, at the moment driving the vast majority of AI research that's going on, their goal is simply to make the machines more and more capable. We have to convince them that, in fact, that's a fool's errand, and it will come back to bite them. And I think the message is getting through. We're seeing this in social media. We now realize that optimizing a fixed objective, like the click-through, the probability that the user is going to click on the content that the social media platform recommends, that optimizing for that type of fixed objective has been catastrophic.
Absolutely.
It might have generated revenue, but the side effects have been enormous. And
yeah, we've seen a lot of changes, including Google already is working on this, changing this whole algorithm. So we will see more. Thank you so much, Stuart. We'll be back with Professor Russell and discussing what are the advantages and the opportunities that AI gives to humankind. What are the new latest advances in AI? What are the technical challenges that stand in front of us, where we try to make further progress immediately after the break.
This program is powered by thevirtual.show, making your offline events virtual.
We're back with Professor Stuart Russell in discussions as part of the WEBIT series AI Architects. We have some great talk here, and we're in discussion on where we are heading next. What are the advantages and the opportunities that AI gives to the humankind? What is your take here?
So the way I think about it, and in many ways the way I've thought about it since I first became enamored of artificial intelligence a long, long time ago, in the mid-70s, is that our intelligence is what gives us a civilization worth living in. And if we can have access to greater intelligence, then we can have a much better civilization. And when you think about it, what general purpose AI can do. So here I don't mean AI for particular tasks like speech recognition or game playing or car driving, but general purpose AI, the kind of AI where you could simply say, hey, drive that car, or hey, let's play a game of chess, or hey, the grass needs cutting, right? You could ask it anything. If you have access to that capability, it is essentially a source of unlimited wealth. If you're in a remote village, you say, we need a school, right? You take out your phone, tap, 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 and by the end of the week, you have a school. And because there aren't lots of expensive humans involved in the process of design and planning and construction and permitting and all the rest, the cost can be essentially reduced to the cost of the raw materials and then the land. So I don't have a way of making more land and raw materials, so those will still have scarcity and therefore cost. But by and large, we will have the same effect as, for example, we've had with travel, right? If you think about crossing the world 200 years ago, if you wanted to go from London to Australia 200 years ago, it would cost you billions of dollars. Probably about 10 years, you would need hundreds or thousands of people involved in the project, and you'd probably be dead by the time you got there. And now we just take out a phone, we go tap, 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 and then you can be in Australia tomorrow, and it's essentially free.
That was before COVID, but hopefully after will be the same, right?
Once they let us in, yeah. So that's because of technology, and general purpose AI is a general purpose technology that makes, in some sense, everything free in the same way that travel is free. When I say free, relatively free. The main question, I think, is going to be one of politics, right? If this source of wealth becomes available, how will we make sure, first of all, that it's shared fairly and beneficially across the entire world? And then how do we humans relate to this new world, right? What is our role going to be? And how do we ensure that our population remains engaged in the process of civilization? I think that's a really difficult cultural question. And I think there are countries, for example, that rely on vast resources of oil in the Middle East, where they're starting to face this question. They have a tap that they turn on and it generates wealth. But what does everybody do in the meantime? And I think it's a significant issue. It's a cultural issue. It's not something that we technologists can solve. But if we don't solve it, we face what might call the Wall-E world. So if you've seen the movie Wall-E, humanity is basically on a cruise ship where the cruise goes on forever, and humanity are just passengers. And if you're just a passenger on a cruise ship, why would you need to learn anything, go to school, become proficient in any skill when there's no need for it? You're just pampered and looked after, and as a result, enfeebled. And we don't want, at least I don't want, to be a participant in the enfeeblement of the human race over the rest of this century.
Stuart, we've seen through human history, at every time there is accumulation of additional wealth, because what you're describing is what we all believe in, and that's the mission of our global community and WEBIT to basically, through technology, to lead to abundance of opportunities and to kind of move to the next level, escaping the scarcity of resources set as economics framework by Keynes and their followers. But every time we see that there is a abundance of wealth, then there was something terrible happening. First, it was slavery. People were equal. Then the slavery came. During feudalism, it was the next level of tools and enslaved villagers that have no right to move, etc., etc. And many people fear now that this new level will, they call it, whatever, digital slavery or stuff. And we see some countries, I wouldn't name them, but we all know what I'm talking about, are actually working quite a lot into this direction. So maybe if you can reflect here and further touch base on what are the current advancement and the latest updates with AI, which we see today.
Sure. So I assume that all of the audience are familiar with what's happened over the last decade with the advent of deep learning, or should I say the popularization of deep learning, because deep learning as a technology goes back to the early 90s with work at Bell Labs by Jan LeCun and others. And that's created new capabilities, primarily in the area of perception. So visual perception, speech perception has dramatically improved. And we are in the process of finding all of the economic niches where that can add value and create new capabilities that didn't exist before. And I think the flagship project there is the self-driving car. And if that works, and let's say I've never been as optimistic as some of the most optimistic projections that we've seen. I worked on self-driving cars starting in around 1993, and it's a very difficult problem. But I think we're making enough progress that we will see them being available, at least for restricted circumstances, in this decade. And that will start to have a really profound impact on safety, on the free flow of traffic, on mobility for people who can't drive by themselves, lowering the cost of transportation to almost nothing. So, if we can do that, that will more than justify all the investment we've ever made in artificial intelligence since the beginning. So that flagship project needs to succeed. If it fails, if it turns out that it's too difficult and the investors pull out, then I worry that we might actually see a bit of an AI winter, as we saw in the late 1980s when the expert system boom fizzled out because the technology wasn't up to the task. So there are many other areas, I think, that will benefit in this decade because of advances in language understanding. And so that means being able to convert, whether it's human speech or text, emails, chats, et cetera, into meaningful internal content that the machine can reason with and problem solve with. That capability is something that we've been working on for 60 years now. And it's been demonstrated very successfully in very narrow areas. But if it becomes generally available, then the range of economic applications with high value for this technology would be much greater, I think, than the range of applications of visual perception. Because 80% of the Western economy is service industries, and service industries rely on communication among people. And so now it's possible that the machine becomes part of that communication network in a natural way. So that would be huge for personal assistants, for example, that can help you run your day-to-day life. And in the same way that CEOs and prime ministers have very effective executive assistants who manage everything, that would be available now to everybody. I think that would be a huge boon in terms of the quality of life.
We had here a guest, the founder of XAI. I'm not sure if you have used that service. Obviously, it needs a lot of further development improvement, but it was, I think, the pioneer in personal assistance, since you finally mentioned it.
So because great. I just want to mention one more thing, which is what I think is the biggest opportunity is education. So up to now, AI tutoring systems, as they're called, have been extremely limited by the fact that they cannot communicate with the student. They cannot speak to them. They cannot answer questions because they don't understand the language that the student speaks. So when that changes, then I think we have a huge opportunity to deliver high quality education to everybody in the world, which is probably far more important than the self-driving car.
It sounds absolutely logical, but at the same time, if you look at it, I would have bet that one of the few professions that will not be obsolete in the future would be, let's say, a teacher, especially in the early stages when you need the human touch. But there's been this discussion for a long time already that how AI will change the society. In particular, whether AI is going to disrupt employment on a massive scale to lead to dependency. Could you please comment on this? And our time really flew away. We only have like less than 4 minutes left, but I would love to hear your answer to this particular question, because a lot of the WEBIT community members are working on social systems based on kind of synergy with what the future holds for us.
Yeah. So there's a lot of to and fro argument in the economics community about this, but I think the point is pretty straightforward. If you automate physical labor and you automate mental labor, then what's left? And I think there is an answer. The answer is, you might call it emotional labor. The ability of people to help each other directly in person-to-person relationships. And my guess is that will be the career for the future. And it will rely, for it to be an effective career, it will have to rely on science that doesn't yet exist. We've spent almost no money on the science of how one person can make the life of another better. And this requires a huge change in our research base, in our education system, in the professionalization of these kinds of skills that will take decades to achieve, and we need to move forward with it soon. Otherwise, we're going to have a very rocky and unpleasant transition.
Thank you so much. Well, beautiful WEBIT community, another opportunity for you to give a thought on our discussions. Last week, we had interesting discussion with leading negotiator for banning autonomous weapons. I would have asked Professor Russell on that topic too, but unfortunately, our time has run, and I'm very grateful, Stuart, for joining us, having this discussion with the WEBIT community, which will be also available for on demand on our website. And I very much look forward to the opportunity and pleasure and honor to welcome you back, either in our beautiful virtual studios or hopefully also in person. So thank you again for taking time and sharing with us the beauty of your mind. I am absolutely looking forward to meet again, and wonderful WEBIT community. I look forward to see you next week, Tuesday, same time. Thank you all for attending, and have a great day. Thank you.
This program is powered by thevirtual.show, making your offline events virtual.